will know. Today, our guest speaker is from Rackspace. It's Ken Crandall. And I'll turn it over to him shortly. Just some housekeeping items. Go ahead and get food. There's always a ton of food here, so go get food. You can get food while I'm talking. You can get food while he's talking, but it's better if you do it while I'm talking, because I don't add value. Down here, there's a number of Frisbees, collapsible Frisbees, and a bunch of stickers. And I'm just happy I'm happy to get rid of any of these. And I did pretty good at the last meetup. I got rid of almost everything I brought from the PTG in Atlanta. Next month is the OpenStack Summit in Boston, which also combines the first OpenStack forum. A lot of us are operators, and we'll be attending some forum sessions and maybe leading some forum sessions. A show of hands, who's going to Boston? Got a half dozen or more. That's good. So I'll see some of you there. Let me see all of you there. And then I haven't planned a May meeting yet for the Colorado meetup, but likely it will either be something I find fascinating in Boston or just a roundup of what I find in Boston. And that'll schedule as TBD at this point. Let's see. Seems like there was one other thing. I'm missing it though. There's food across the hall. Come on in. Come on in. Take a Ceph sticker. I know you want one.
Sure.
So take any stickers.
I don't work for those guys.
Oh, you don't work? Oh, you've changed careers again. Let's see. There's food across the hall, restrooms across the hall. And I guess I'm going to turn it over to Ken Crandall. And let's give him a round of applause and welcome him to Louisville, Colorado.
Hi, is the mic working all right?
Yep.
Cool. At least something worked today. Okay. So this is like, I hope you guys will bear with me. This is like the 8th time overall I've given this presentation, so I'm pretty good at it. However, it's like the 4th time in 4 days, and so I'm a little punchy. Not to mention the fact that there's some really interesting things that happened this morning at DockerCon that kind of, oh, go ahead, there's a timeout.
Okay, timeout. I actually have had the author sign some books. The book is called Common OpenStack Deployments. Okay. So who was the first one here tonight that doesn't already have one? You were probably first or second. You guys can fight over it. All right. Who just walked in? Did you just walk in? Common OpenStack deployments. Okay. Would the author please rise? Or how about give a hand to Matt Fisher right here? Yeah, we'll bring more next time. All right, I got a 3rd copy. Who wants it? All right, right there. Yeah. Yeah.
Oh, no worries. If I were to write a book, it'd be Uncommon OpenStack Deployment, because
They're all uncommon.
that's all. Yeah, exactly. That's all I seem to deal with. Anyway, like I said, I'm like on my 4th day of my 4-day world tour here, so I'm a little goofy. So please bear with me. It's also been a long time since I've spent any time at altitude, so I might be up here huffing and puffing. Okay. Oh, this is in a really good spot where I can't read anything. There we go. Cool. Let me get that out of the way. All right. Nothing more annoying when the little Zoom window hides your actual slide content. Which I should know these slides because I've been doing this, but anyway. So a little bit about myself. My name is Ken Crandall. I am a senior solutions architect at Rackspace for our RPC product, our private cloud product. I'm based in Portland, Oregon, so a little bit north and west of here, where it's actually slightly less rainy than it is here right now, but also colder, so very weird. My focus is helping customers design and implement private clouds with OpenStack, and we're adding Kubernetes to that mix as well too. So that's really, this is really a well-timed presentation for me to be giving because I've had a lot of comments and questions about how containers and OpenStack work together or don't in various contexts. And so this is basically the sum of lots and lots of internal and customer conversations I've been having, kind of distilling it down to what I hope is really good information and really, establishes a really good set of kind of talking points and vocabulary that you can have constructive conversations with the people about. So my background, I've been working with OpenStack since late 2013. My first release I worked with Savannah. I started when I was back at Oracle. After Oracle, I was at Marianas for a while before I came to Rackspace. And I've also been doing Linux and open source for a long, long time. So all this open source software infrastructure thing is pretty old hat for me, so to speak. And I've kind of done the rounds on both sides of the table in the industry. I've been on the vendor side as well as the industry side several times. And I find I like it more on the side I'm at now because I like new challenges and helping people and not getting caught up in corporate politics. So fortunately, I kind of get to dodge that bullet. So, of course, that won't work. Okay, there we go. So quick disclaimer. This presentation, like I said, is the sum of several conversations I've had with customers and internally, but it represents my opinion. So I'm not representing Rackspace or Rackspace's opinions in this presentation. If you want the Rackspace perspective on something, I can certainly give it to you. In a lot of cases, it will be quite well aligned with mine, surprise, surprise, but I'm not speaking officially for the company in this capacity. So if I say anything and either you're a racker and you know that's not the way we do things, or you disagree with it, then then it's entirely my fault and Rackspace is above reproach. So what I'm here to talk about. So I've kind of broken this down into 4 parts. The first part is debunking the myth of competition. Usually the very first question I get when it comes to containers is, should I be using containers or OpenStack? And usually after a long sigh, or I try and keep it all inside, I say, well, let's back up a second. And so we'll cover that part of the conversation. Next, we'll talk about specifically what are the roles in containers are very useful. Because containers being kind of the new hotness, everyone wants to containerize all the things all the time, and there's times when it's good, there's times when it's not so good, and it's got really understanding those kinds of those aspects of things is really, really helpful, and leads us to the second part of how you can use OpenStack to kind of bring everything together. And then the last little bit are some interesting little tidbits that I call the future, which is kind of like where things could get even more interesting moving forward. So as with all myths, the myth of competition of containers and OpenStack starts out as people kind of hearing other people's opinions and turning to assume them as facts. So just like people heard, oh, the world is flat, if you go too far, you'll sail off the edge. People have been hearing, oh, containers and cloud compete with one another. You've got to be doing either or I don't want to do VMs anymore. I don't want to do virtualization anymore. I want to do containers. Well, to start things off, before we can have a real productive talk, we need to settle on our terminology. And this is where I said things got real interesting this morning, because there were some really interesting announcements this morning that kind of preempt some of the interesting things I'm going to talk about. So to start right off, we'll start with the easy one. So when we say OpenStack, most people think of OpenStack as being this. Now everyone should probably recognize this diagram. This has been in OpenStack's literature for a long time. And it basically talks about the basic IaaS components of OpenStack. But I argue, since we switched to Big Ten governance, that the definition of OpenStack should really change. It should no longer be, how do I build an IaaS cloud? But now this kind of eye chart of all the different services that are just all the ones that are official supported Neutron projects. So all these different services we can deploy. I think the definition kind of expanded. So instead of thinking of it as how do I, a construction kit for building an IaaS, it's a set of services and APIs for software-driven orchestration of infrastructure. Or to put it quickly, it's how do I use APIs to tell my, if you want to use VMware's terminology, software-driven data center, it's how do I start doing interesting things programmatically versus having to set it up, or even more important, and we'll talk about later, it's how do you have a service-oriented view versus a server-oriented view. And this is where things got interesting. So how many people saw the whole Docker and Moby announcement this morning? Hands higher. I can't see you when you're doing this. Second of all, okay, let me back up. I should have asked this question earlier. How many people here have, how many of you guys have a let's say, at least a passing knowledge or use containers, either exploratorily or in production or in your environments? Sweet. So hopefully this doesn't make my entire talk redundant. So of those, how many use Docker? Kubernetes? Okay, fewer. Cool. So at least this should be somewhat interesting. Usually the very first thing that I have part of the conversation when I rewind from that, should I use Docker or should I use containers or VMs, is when I say containers, do they really mean Docker? And so Docker becomes synonymous with containers. Well, it used to be a lot more confusing until this morning, but thanks to this lovely announcement this morning, this seems to be a bit more clear. So instead of Docker meaning about 5 different things, they've this is the best of my understanding, they've cleared it up that the project, the open source stuff, is now called Moby, and the company or the product they do is now called Docker. So please feel free to correct me if it's wrong. I was reading this on very few hours of sleep and kind of having that oh no moment on the plane when like my presentation is totally wrong. So rather than kind of go through and redo my presentation last minute, I just put these lovely little boxes on here where I think things are maybe a little different than they used to be. And so I'm going to still call it Docker for now, as we'll talk about in a second. But containers can also mean more. So I asked earlier about who's used Kubernetes. Well, Kubernetes is container stuff. So is Rocket, and so does Docker Swarm and Mesos and other things. Those are all the container landscape is very, very complex, and it's unclear what's competitive with what. It's unclear what's complementary with what. And unless you kind of sit down a particular path and really start to dig into it yourself, it can be confusing. What am I already doing? What do I need? And what do I need to do? So let's, again, I was going to get into this whole thing about defining containers and defining what Docker meant and everything, but I don't need to do that anymore. So I'm going to call them Docker containers still. I don't know if you're supposed to call them Moby containers or Moby files now or whatever. Last I heard, Moby was a guy who did music in New York and, and didn't eat animals. And I think Moby's an interesting name considering their whole thing is Docker is a whale carrying, containers, but in the book, the whale sank the ship. So again, I'm not in marketing, but I'm going to call them Docker containers, mostly out of intellectual muscle memory. And also because that's what I said in all my slides and I don't want to be second guessing myself. But we all agree that if I say Docker containers, you won't hold it against me if they come out tomorrow and say, you're supposed to call them Moby widgets or something. So now that we agreed that Docker containers is cool and I can go past, put all the Moby stuff behind me. There's still kind of the part 2 of, what do we call this next added on piece, these orchestration engines. And like I said, there's several different ones to choose from. There's Mesos, Docker Swarm, Kubernetes. And there's cases where you have Kubernetes and Mesos together, one running the other or the other running the, I mean, they're all kind of a strange mishmash Venn diagram of services and functions they provide. And they're being combined in very new and interesting ways all the time. So they give all sorts of added function on top of just a straight Docker container that you're running, from the command line, like HA scaling, service availability, service definition, and so on. And they essentially, I hate to use the P word, but they essentially start to provide a container platform. So I'm going to pick just one to talk about because otherwise we could be here for days. And I'm going to pick Kubernetes. And I forgot to introduce what I forgot to mention earlier. I have these little, you'll notice these little comments. So rather than being footnotes, they're like snark notes. There are these little notes down there to see if you're paying attention. So I'm going to pick Kubernetes because it's my presentation and I get to pick. But Kubernetes is also the one I have the most familiarity with and get to spend the most time with. And it gives you a lot of goodies when working with Docker containers, like declarative configuration, where you tell Kubernetes the way you want things to be, and it does its best to make them that way and keep them that way. Automated deployment, rules-based scaling, definition of services, service HA, and then now there's even better support for stateful applications. And it's almost a pass. And I say almost because at our OpenStack meetup in Portland, it was either last week or the week before. I don't know how many of you have gotten the opportunity to see Kelsey Hightower speak about Kubernetes, but if you do go see him because he's a rock star. And I get to see him all the time because he lives in Portland too, and so we often bump into each other at meetups all the time. And he said something really cool. When our host was showing off how they deployed Kubernetes in production, they had basically built a domain-specific language on top of it that did much, much more than define just what a Docker file has, or a Kubernetes service, or a Kubernetes cluster, or all the different kind of YAML files that you use to define things. They essentially crammed it in one thing. And when I looked at it, of course, being an OpenStack guy, I thought, oh, this looks a lot like a heat template. That's really kind of what it was. It was kind of a declarative way of orchestrating their CI/CD system, saying, start with source code and services over here and spit out my running application. And what Kelsey said was, Kubernetes is providing this kind of toolkit where people are building their own little mini passes out of their CI/CD pipelines. And that really stuck with me. Because it was very similar to some of the things that I'm going to talk about later. And so it is almost a platform as a service, but it's not quite the same thing as, to say, like Pivotal Cloud Foundry, or the extra stuff that OpenShift gives you from Red Hat, and some of the other things that market themselves as PaaS systems. So when we assemble all these definitions and now lay them out in front of us, what do we have? We have containers. So applications and their runtimes packaged in a standardized format. We have container orchestration that gives us ways to manage containers and turn them into service definitions. Then we have OpenStack, which is a set of APIs for software-driven orchestration of services. These don't sound like they overlap very much. They're not very competitive with each other. Like I said, do they compete? Not really. But we've all been taught that they do compete, because I don't know how many of you have seen this picture or pictures a lot like it. Often when containers are first coming out, the very first thing they start saying is, see, look, you don't need this big, heavy guest OS image and this hypervisor. Instead, you can do things with the container engine. Well, yes, it's true containers spin up quicker. Yes, it's true that they're much lighter weight, and yes, you can fit much more angels on the head of a pin when you're talking about containers versus VMs. But, and they're primarily targeting developers with this audience. And as you know, the more things developers have to worry about between starting and developing code, the more yaks they have to shave to get there, the crankier they get. And apologies to any developers in the audience. I come from the ops side. So devs don't want to worry about servers, which is why they think serverless is so cool. And like I said in my little snark line here, they find that even more appealing. And I'm not really going to talk about serverless today, but I have to get this in there. Everything runs on someone's server somewhere, even serverless stuff. So I really don't like that. That's kind of like saying, it's over there. It's someone else's problem. I'm going to push the peas around the plate so they're not in front of me. And so instead of this picture, I really could have put this one, which is on my laptop on my work laptop. This is my personal one, front and center. And I often remind customers of this. So when we get into the whole public cloud versus private cloud versus should I do this or should I do that, I'm like, it's all servers running somewhere. It's just how you're consuming it, how it's priced, and whose responsibility for it. So by looking at our definitions, they really don't compete. Containers are an application delivery mechanism, and OpenStack is about running cloud and running applications. So containers are part of a cloud, and this, again, makes them complementary instead of competitive. So this kind of is the path I lead customers down from that, should I be doing this or that, to saying, well, one serves this uses, one serves that uses, and it's really a good way to diffuse that argument, because our initial instinct is to get defensive about our whatever is close to us. Like being an ops guy, particularly being an OpenStack guy, my initial instinct is to get very defensive and say, well, no, of course you should be doing OpenStack and doing cloud. Well, having to kind of wind it out and say, okay, what are containers really good for? Which is the next part, the next section. Once we learn that, we kind of learn, okay, how do I turn this into a cogent discussion where we're solving, in my case, my customer's needs, and internally it could be your internal customer's needs. How are we actually solving problems versus arguing on technological implementation? So that's part two, the roles and uses of containers. And the obligatory stack of containers picture in every container presentation anywhere. So containers have really changed software delivery. I'm an ex-Red Hat person, and started at Red Hat in '99, worked there through about 2006. So through the genesis of Red Hat Enterprise Linux, I'm part of the team that helped create Satellite Server, which is now gone. Is now being replaced by Cobbler and other more interesting things. And one of the things that we always heard from customers was the whole dependency hell problem of packages. Raise your hand if you've dealt with that. If you're not raising your hand, you're lying. So containers really do something interesting they shift the burden of dependencies from the ops to the dev. And when you deliver an application in a container, there's no installer, there's no package, there's no dependencies. You just have a container to run. And provided you build it correctly, you can run the exact same container definition on your laptop as you're running in production in your server. And that's huge. And probably the even better aspect of it is services with different dependencies. So you've got 2 different versions of Python, 2 different versions of something, little like libc, can coexist and run the same system. Now, the gotcha is containers share the same kernel. So we have to, we'll talk again more about kind of some of the risks and choices that are behind that later. But it really, it's really actually a good way. It took me a while to kind of buy into it, but it's a great way to deploy software. So, Docker is the new RPM, or the new D package if you're an Ubuntu Debian guy. Or are there any other package formats left? I guess Slackware still uses tarball. There'll probably always will be someone inventing a new, there's IPKs, I forgot there's a bunch. But most of the container native operating systems are not really using package manager except in limited ways. So if you're using Atomic, Host, Alpine Linux, Snappy, Photon, they might use RPM or dpackage, but they use it to kind of compose a relatively static image and then as the basis of your container. And to me, this is absolutely the right way to do this. One of the other interesting announcements from DockerCon was, I want to say it was something called like Linux Kit, which is basically integrating an entire Linux build into your CI/CD pipeline. And I had the biggest sense of deja vu when I heard that. One of the other things I did way back at Red Hat was I was part of the very first group to take the very first RHC exam. And if you took the old RHC exams, you remember you had to compile and build and install your own running kernel. And then we got smart a couple of years later and said, holy crap, every single person out there running a completely different kernel is a completely unsupported mess. So part of me kind of still recoils in horror at the thought of every single app build pipeline in just one organization, much less all the organizations, having a completely different Linux kernel. And the security footprint of that is going to be mind-bogglingly insane. So I still subscribe to kind of this model. And, I still need some convincing to say, yeah, you really should be building your own Linux kernel for every single application you do. But kind of the other artifact of this is it's not necessary to use packages to compose containers. Once you have this base OS image that's essentially flat, you can pull everything out of your version control system. And lots of legacy software does this. So I worked at Oracle for 5 years. I'm now been Oracle free for 3 years. Kind of like a sobriety statement. If you spend any time with Oracle, you realize it ships like its own Python, TickleTK, Perl, JVM. I'm probably forgetting about 50 things else. Same thing with WebSphere. Same thing with other large software projects. They've been doing this for a long time. Rather than having to say, I need to make this work on every version of Perl across every Linux distribution, HPUX, AIX, DGUX, VAX VMS, Windows, whatever else you're going to run it on. Instead, I'm just going to include it with me and just build it. And in a way, this approach has been around for a long time. Same way, if you ever want to have fun, go talk about the new hotness that is containers with old Solaris admins. They get really grumpy. Like, we've had containers for 10 years. Yes, but you ran it on Solaris. And then run away and duck. That was what I did for fun at Oracle, by the way. But like anything else, it means timing is everything, right? So combining a lot of these approaches and kind of picking and choosing from a lot of wise, things people have done before you, or to use that great phrase, standing on the shoulders of giants. We're slowly kind of being able to cherry pick these really smart approaches that solve problems similar problems around in the past and assemble them together into, something really new. I also like the fact that containers are very DevOpsy. Like I said before, it moves the apps closer to the devy folks, the developers. All the library dependencies are now treated equally. They're theirs. Which means, that takes away a whole class of problems, right? It's like, oh, you don't have the right, I need a different version of Python than you install. The different one than all my system tools use and that every other tool in the system uses. Great, and then, or I need to do some LD library preload madness, or there's all sorts of things we've done over the years to try and get this big monolithic hunk of software that somebody wrote running on a machine and keeping it running. And being able to get rid of that makes us OPSI folks really happy. Allows us to focus on more SRE type functions, such as our SLAs, keeping things running and keeping the dial tone on when people pick up the phone. But it also provides a nice common interface for devs and ops. It means now, like I said, it went from being, okay, kind of horse trading to see who managed what dependencies to pushing them all on the table and say, they're yours, guys. We will guarantee you a platform you can run on. We will guarantee it'll work in this particular way. We'll guarantee it will consume Docker file container format. Go nuts. But don't come to us if you start having, library mismatch problems, because not our fault anymore. But the other nice thing about that is, essentially what I said, what I just did was there becomes a contract between the application deployment team, or portion of the team that does application deployment, and the portion of the team that keeps the lights on. And this whole notion of IT by contract becomes very, very important in the cloud world. And I'll touch more on that a little bit later. Now, with anything else, containers are great. They're new hotness, but there's still some gaps. My favorite thing is Docker Compose doesn't really compose things. It assembles a bunch of layers. Like they say compose, more like the way you compose a sandwich from lettuce and tomatoes and meat and cheese and buns. It's a workaround for the fact that you can't run services inside of other services. Now that's good. That's a very, very good thing, because basically we don't need people recreating entire operating systems inside of their Docker containers. We have that. It was called LXC, and it's got its uses, but it kind of defeats the purpose.
You finally mentioned the other Docker.
Oh, no. There's a lot more LXC coming. Stay tuned. This format does not work incredibly well for legacy applications. It forces you into essentially a microservice architecture. One main service per your container. It can have little helpers inside, but you can't launch a container that spawns other containers, which is a good thing, because that would be a major glaring security hole. The other thing containers don't really deal with is state. And when I go talk to Kubernetes folks, I'm like, great. They're like, oh, we have, they talking about all the great stuff in stateful sets. And then they tell me, but don't put any stateful stuff in them. What? Okay. Where should my state go? Somewhere else. The cloud, there is no cloud. There's just other person's computers come to mind. I'm like, okay, where else? So I bring up, being an ex-Oracle guy, I throw down my trump card and say, what about the database? Oh, the database should run on a server over there. I'm like, not in my cloud. That's the whole reason I'm building clouds. I run all my software. And that's the reason I'm containerizing, so I can easily buy software. Oh, not databases. Those are horrible for containers. But you want a database in everything that you do. Again, the real world's messy. But to that effect, Oracle just announced today that they're officially supporting Docker containers for Oracle database and a bunch of other stuff. I can't wait to see the size of the Docker pull on those. and in all fairness, I have run rack clusters in Docker containers. I did that a couple of years ago. It was about as fun as it sounds, and it worked surprisingly well. And I think that as for all the fun I make of Oracle, if they truly embrace it and they do it the right way, it's going to become a much easier way to stand up, large database clusters than having to pay millions of dollars for Oracle consultants to come and ruin your servers. So now we've kind of disseminated the definitions and kind of figured out what we're talking about. We've discovered what containers are good at, what they're not so good at. Now, how can we bring this all together with OpenStack? And there's a slide I should have used, because the rug brings the room all together. Oh, come on. Okay, that's the last joke. I'll be serious now. So in all fairness, OpenStack has been containerized for a long time. RPC, my product at OpenStack, at Rackspace, is based on a project called OpenStack Ansible, which runs all of the OpenStack services in LXC containers. Now, like I said before, that was I kind of view that as a cheat because LXC containers are great. They're much faster than spinning a VM. You can do really neat things. Some things don't work so well in them, like serving NFS out of them, unless you're really deranged, like me. But OpenStack Ansible utilized the fact that it's much easier to build a set of services in LXC containers that then can be later scaled to their own, you can run one LXC container on a big physical machine and essentially have that whole machine to yourself. But by having that encapsulated in a container definition, I can start small and can ram a bunch of containers onto smaller meta systems and then grow them as those services grow up. And it's not quite the same as Docker and Kubernetes. LXC is what I call a system container versus Docker's view of an application container. When you log into an LXC container, it looks like you're logging in a VM. It's got an essentially complete system inside. But like I said, it shares the kernel with the host. So it still has all of the same security questions that containers can bring up. And in fact, LXC containers can often bring up more because you can imagine the fun of you're running systemd inside a container that's running on a system with systemd, and it took a long time for those things to play well together, and they still don't sometimes. Networking can be tricky, particularly if you're deploying your Neutron API controllers and endpoints in LXC containers, and you're using like VXLAN tunneling and Open vSwitch, and the backend networking for your LXC host is also Open vSwitch. Yeah, figuring out what network namespace I was in at what level, kind of having that network inception is, I had some late nights making that work, but I did make it work, and when it worked, it was so cool. But it can be tricky. There's no automatic HA for containers yet. Now, LXD, which is kind of the demonizing, more grown-up version of LXC that Canonical's been working on, is going to bring a lot of those things. Right now, it only works on certain versions of Ubuntu that they see fit to make it work on. I'm hoping that it'll become more standardized because there's definitely a role for LXC and LXD containers. But we don't yet have HA like we do with VMs. And then storage also has its quirks. Like you cannot serve, for example, iSCSI storage out of an LXC container. And it's the same kind of reason serving NFS out of an LXC container can be bad. Most of it has to do with security contexts. I'm not even talking. I'm talking about C groups and C group permissions. I'm not even talking about SC Linux. You bring SC Linux in there, and oh boy, it's a party. But bottom line is, when you start doing interesting like networking things, it basically all boils down to networking. And the thing about LXC containers is they assume they're a system. They don't know. They're like in their own happy little world, and they don't realize that they're running in a simulation. So their assumptions, it's like all of a sudden it's like, what do you mean I can't like do block device options on this hardware? It's my hardware. Well, it's not really the hardware, and they don't know it. So again, as those things get worked out, it's going to be better. But making the assumption of, oh, I have a system in there, really can break your noodle. So I think that OpenStack and Kubernetes are an even better fit, kind of like chocolate and peanut butter. And there's been many cases of OpenStack on Kubernetes. So there's Colo Kubernetes, which is my personal favorite. There's Stackinetes that CoreOS did. The others with an asterisk that I didn't. Funny story behind that. Mirantis just announced their Mirantis Cloud Platform, which was the product I was working on before I left Mirantis. And now I can actually mention it. That was what that asterisk was supposed to be down there. And then I realized I can't mention that. No one knows about it yet, and I will get in trouble. But now I can mention it. Mirantis Cloud Platform uses a Dockerized control plane running on Kubernetes as well. And then you could do it the other way and do Kubernetes and OpenStack with projects like Magnum and Murano. And there's even some really cool presentations some Red Hat guys are doing right now, which is Kubernetes and OpenStack and Kubernetes, kind of like an Oreo. And there's some really neat stuff with that as well. So, and really what it boils down to is starting to treat the OpenStack services more like microservices, which I think is, again, the right idea. So why I run OpenStack with containers. Containerizing each of your services. So Keystone, your API services, Horizon, those are good examples. Ceph, don't do it. Well, Ceph controllers and certain things you can. Monitors will work well. Other things, not so much. Anything that has to actually touch the metal should not really be in a container. And it's got some benefits. I mean, you've got an automatic isolation. You don't have to do rampant Python virtual environments everywhere. And as the services mature, as OpenStack matures, and we now have version services and the ability to actually migrate, and in some cases live migrate, it means you can spin down old versions of services, keeping your load balancer up for your end users, and bringing up new versions of services, migrating your schemas over, do all those things in a very structured, organized way, while keeping that dial tone on when they pick up the phone. And kind of taking, again, a more service-oriented viewpoint, rather than what we've done traditionally, which is having a server-oriented viewpoint, is really important. And I said earlier that also that notion of IT by contract, and when you think about it, what really kind of gave me that notion, first of all, it's not my idea. I wish I could say it was. It's how they do things at Amazon. I have a lot of friends who work at Amazon. I'm originally from the Northwest. They keep trying to come get me to work at Amazon, but I think it's a cult. It's a nice cult, but still, I don't want to move up to Seattle. It rains too much. I like Portland, where it rains only this much less. But they do. But that's a really good idea. And the thing is anytime a new service comes up, they're basically defining their SLA and their API with the rest of the world, and everyone interacts with them that way, whether it's through AWS Web Console, whether it's internally, and it really provides some really useful functions that in my line of work we call business transformation. Because if you try and implement DevOps by just saying, hey, we're creating a DevOps team, you're doing it wrong. You really need to rethink the way you run your business, and I think IT by contract is the way to do that. And it solves a lot of problems that you can run into and that exist in current organizations, especially as you scale into large organizations. It also means that it's easy to sunset older things rather than having them ride the long tail in the sunset. They'll still run 20-year-old, 30-year-old, 40-year-old VAX machines in the basement. Incidentally, my first job out of college was down in Littleton running 30-year-old VAX machines in the basement. That was 20 years ago. I think they're still there. I'll kind of get into more of this later, but we already have service discovery in Keystone, and we're already starting to do things the right way. We're already starting to take, from the beginning, there've been a rather than having to, we still have to configure a bajillion config files, and I don't like that. But by putting our service endpoints into Keystone, Cinder doesn't need to have, you don't need to configure Swift's config files on every single box out there to tell it where it is. It can go query Keystone and figure out where's my Swift deployment and then consume it. And if I need to change my Swift deployment, I can change it one place and everyone else can consume it. Now, there might be better ways to do that moving forward, but we're headed down the right path, and that's good, because it means it's not really rethinking the way that we're doing things, but it might be rethinking the way that we're implementing it. On the other half, why can OpenStack help with running containers? So this goes back to the very first question I posed of containers versus VMs. And the thing is, there's things that are still not very production friendly with containers. Networking is one of them. Now, like I said, you can deploy Kubernetes on top of, like in both Murano. We did that at Mirantis several years ago. But the thing is you're running it just like any other app on top of OpenStack. And Kubernetes has its own views of how networking the world should be and what levels of control it should have. And those don't always exist well in the tenant-oriented model that OpenStack has. Now, my third point is you get multi-tenancy. That's important, because if you have to have multiple Kubernetes deployments that cannot interact, they're just now getting to the concept of multi-tenancy in 1.6, and it's tech preview and basically don't run it in production. Well, that kind of sucks if you have to run it in production. There are a couple good answers to this. One is Neutron and SDN. Now, by combining with some of the more advanced SDN solutions, whether it's Cisco ACI, Contrail or Open Contrail with Juniper, Calico, and some of the others, both Kubernetes and OpenStack have essentially plugins into that networking fabric. And that's nice, because that means rather than each assuming they're going to have full control of the network, they're basically seeding that to what can become a unified network management framework. And that means even if you're running Kubernetes as a tenant inside of OpenStack, it's interfacing with the APIs of your SDN and your policies being set up there. So you have isolation for the APIs for your developers between multiple Kubernetes things, but how apps can talk to one another, how servers can talk to one another, who can get out, who can see the world, who the world can see in, is all being managed at the network policy at a unified network policy level. And that's important because, you know, what we want to get away from is, oh, okay, I've got my container runtimes over here, and they've got this whole networking SDN stack, and then they basically wrap up to my aggregate switches in my switching world, and the networking guys have to deal with it. And then over here, I've got my VMware environment, and it does the same thing with NSX, and it talks to the physical switching layer, and then I've got to start setting ports and VPNs and stuff. And then over here, I build OpenStack, and I do it all again. Well, we want to get away from islands of technology. We want them to start talking to one another. And this is also where OpenStack really shines. I said, and that, again, if you look at that new definition, I like to say, you know, that OpenStack provides you a set of standardized APIs for dealing with certain types of services. If you want Kubernetes, a VM or a pod in Kubernetes, to have access to a block device, why not just make a Cinder call and get a block device? Why not make Cinder your standardized API for getting block devices everywhere? I mean, that's where Magnum is really going to shine, and all the stuff like Courier at the networking level and stuff like that. By building, kind of having those shunts and saying, okay, now I'm slicing my infrastructure into these horizontal things, and I'm building contracts between the layers, and so that anytime I want a block device, I make a Cinder call. Now today it might be running, you know, it might be small, maybe running, you know, on a cluster of Linux LVM. I might want to move that to Ceph. I might want to repurpose my EMC VNX boxes with a Cinder driver. When you're from an implementation perspective, the people consuming it shouldn't care. As long as I'm meeting my SLAs, and as long as I'm fulfilling my contracted APIs, they lose all right. Tell me how I should do it. I mean, if you think about I use the dial tone instance. If you pick up the phone and use the dial tone on the phone, if you're making a phone call, you make your phone call goes through, you don't care, you're happy. If the olden days, if you could get your modem connect, you were happy, you didn't care. Just instant you pick it up and you get a fast dial tone, then you start getting on the phone with the telephony guys. You're like, what's wrong? Well, you know, we're having this problem. Well, how many outbound trucks do you have? And everyone starts solving your problems for you. And when you have 100 unhappy customers all trying to solve your problems for you, life is not fun. But if you're meeting your contracted APIs, you know, your contracts and your SLA levels, you know, you basically you're putting up, you're doing what you say you're going to do. You're meeting the expectations that you set. And how you implement it, no one cares when they pick up, if there's a dial tone, if it's POTS or VoIP, as long as their call goes through. And if, for example, you pick it up, you do get a fast busy, and you can't make a call, is it normal everyday circumstances, in which case they failed in their SLA to you? Or was there a minor earthquake, and now everyone's trying to call, you know, their daycare and find out their kids are okay, and it's an extenuating circumstance, in which case all may be forgiven because the phone isn't designed for every single person in the company to all make a call at once and have calls all incoming to them at once from their loved ones. And that happened when I lived in California. So it's not unreasonable, but also it was, you know, again, that's one of those things where you're designing for the bell curve, not the Six Sigma outliers. But again, if it's part of my SLA and I'm delivering on it, then that gives you the freedom to implement whichever way is most expedient, you know, gives you the best OpEx or CapEx savings, depending on what to optimize for. Make sure I can optimize for performance. Heck, I might even, you know, I might just implement that API and outsource it. Doesn't matter. You know, the API is all that really matters. But it's still early. So I think I kind of blew through this slide talking last time. So yeah, I talked about networking. Storage, there is Magnum Cinder integration. That blueprint's been approved, but as of when I looked last week, it was still not implemented yet. It means they're still headed the right direction. Again, to me, winning is I only have to provide one kind of way to get volumes, and then I can focus on delivering whether I want to deliver SSD volumes or tiered storage volumes or what have you. But for now, storage is separate. So for right now, you're still essentially running, you know, Kubernetes or any other platform, you know, container runtime as an app if you're running inside of OpenStack. So I'm going to go back to this again. And so the next question goes, okay, if I don't have the integrations yet, why don't I just run it on bare metal? Who remembers about 10, I guess now 11 years ago, of people said, I can't possibly virtualize my app. It's not going to perform well enough. Oh, come on, I can't be the only, okay. And then pretty soon, like a week later, you said, you know what? How's your application doing? Oh, great. It's like running better than ever. What's been virtualized for 2 months? And then they get angry. And then they, then they go through all the stages of grief and then finally get to acceptance and then life is good. But the fact is, everyone thinks their app needs to run on bare metal. Everyone thinks they need, the fastest car and the most CPU and the most RAM. But the fact is, that's always been a way to get around providing accurate requirements. If you have enough RAM and enough CPU speed, any app runs fast. We just don't know what it needs. And the fact is, if you're going to go consume, for example, Kubernetes containers in the public cloud, whether it's GKE, running your own Kubernetes things on GCE or running on AWS, you're running in VMs anyway. You're not running on bare metal. So the fact is unless there really is no good reason to run it, because again, you're basically saying, all that great operational excellence and operational optimization and cost savings I got by virtualizing my environments, I don't want that anymore. I want to go back to managing bare metal servers. And said nobody ever. So, kind of look at it, but to build it into, to be fair, let's build pros and cons. Deploying Kubernetes and VMs makes sense when, again, you want all of that, it's really easy, relatively easy to create, to deploy Kubernetes as an app. You can do it with Heat and Murano, like I said. You can also do it with any of the infrastructure's code tools, so Ansible, Puppet, Chef, and Salt. Has anyone built a good acronym for all 4 of those yet? The other thing I like to tell people is you're talking to me about developing cloud native apps, right? Those are supposed to be scale out. If you need more, just deploy more. I'll make sure you got enough room. Don't tell me, if you need to have faster CPUs, that's not really cloud native, is it? Multi-tenancy is already there, like I said before. Even if segregating dev from production from tests in the prototypical ways, you don't necessarily want to run the risk of somebody hard coding something in a container that, you think everything's great because when you're running in test, because it's running in production, because it's actually accidentally pointing back to some hardwired thing that's back in your test. And then as soon as that guy shuts off his computer for the night and that vagrant box goes down, you have a production crash and no one can figure out why. And then it works fine in the morning when everyone comes in and he turns on his machine and then it breaks. That's never happened to me. But I mean, so you already have multi-tenancy, you already have the benefits it gets. And then, you already have existing processes. So, you've undoubtedly rolled out applications before. This isn't your first rodeo. And if you got the cloud, use it. Don't invent reasons not to use this thing you built. Now, as for inventing reasons when you don't use it, bare metal makes sense in a very few set of situations. One is you don't already have a cloud. So saying, hey, running containers, I'm going to build out a whole cloud first, and then you'll get containers later. Not a good sell. You won't win that argument. So if you're already just managing everything bare metal, then, yeah, you're probably going to want to deploy Kubernetes bare metal too. And kind of the second one is a restating of the first one. You already have a very robust infrastructure designed around deploying bare metal. I mean, people have those wicked cool, hyper automated Kickstart deployments that go from zero, rack and stacked hardware to some highly optimized, super cool, always updated machine. And instead of doing, yum updates, you just blow out new images. Okay, you're not only supremely cool, but okay, I think I can trust you to deploy this on bare metal. You don't need tenant isolation. You just need a big honking bunch of Kubernetes, and you're doing it for internal development, and you don't have a cloud. All right, roll it out on some machines. Or in the case of that extra 5% performance, if you don't give it to them, you'll get fired. And really, unless it's really that reason, don't do it. I mean, run it in the public cloud. Don't run it on bare metal. It's just to me, it's kind of regressing, because the whole point is to build that abstraction layer so that you can operationalize your processes and not having people focused on bare metal. As soon as they start focusing and realize that they're running on bare metal, you will never get them off. You're back to having people hugging their servers until you have to pry them off. So we've talked about I'm going to recap. This is the tell them what you're going to tell them, tell it to them, tell them what you did tell them, and say it again, and say it again. So what we've gone over our definitions. We've talked about how containers are good. We've talked about how containers and OpenStack work together. Now, what are some interesting things that I hope will happen in the future to make it even more better? First of all, I think the microservices approach is very, very good. I've used the term IT by contract, but to me, microservices are very simple. There's an up view and a down view. When we view down, those are the services we consume. We abide by the contracts that they give us. They're services we depend on. They give us an SLA and they give us a set of APIs. So we have interfaces and expectations. We can count on them being robust and reliable. It's not our job to worry about. In a good microservices architecture, every service should be robust and reliable. Now, that's very different than what you hear from developers. Developers say, I assume nothing is reliable. And so what you have, and they're kind of inverting this in my mind. They're saying, I'm going to provide a reliable service, but I can assume nothing below me is reliable. It's kind of backwards, because when you get to the hardware, eventually you're at the bottom, and if what's below you is not reliable, you're building on a very bad foundation. So I view it like saying when you build a building, or if you've ever built like a brick wall or a log wall or a log cabin or something like that, you spend forever making sure that first tier is level. Like that bubble is exactly in the middle. And lo and behold, when you get to the top, you've got a nice structure. If you kind of cheat, then things are not fitting halfway up, and by the top, it's leaning, going to fall over. And you have something that looks like the Shrieking Shack in Harry Potter. So my view, and this might be my ops bias, is I should be able to depend what's below me. Now, that's a hierarchical view. The guy below me basically says, okay, I need to depend what's below me. And if you're the guy on the bottom of the pyramid, those are the biggest, stoutest, strongest guys. That's where you build redundancy into the platform. Now, the up view, the services we provide, we need to make sure that we are the ones providing redundant and highly available services. It's up to us to make sure that we are fulfilling our contract outward. And maybe, inward and outward would be better than up down. Maybe that's my own antiquated thinking of thinking things are actually layered, because if any of you have ever seen, there used to be this diagram that was very much considered the quintessential OpenStack diagram, was by a guy named Ken Peppel. Does anyone remember that diagram? Looks like the route map from United Airlines. And it's basically a way of documenting all the consumes and provides relationships between the original 7 OpenStack projects. And it literally looks like an airline route map, but it's very insightful. It was very useful for those of us deploying OpenStack by hand a long time ago, because when you're trying to build firewall rules, you need to know what's going in, what's going out. But it also gives you the depends on and provides. And so you learn that certain things like Horizon have dependencies, but not many things depend on it. And so you kind of learn where those things are, but it's not a true stack. It's more of a web. And so, but that's really where the contract part becomes important, because you sit there and say, if I have a Neutron API outage, it means I can't request any new networks, but shouldn't the rest of my networks be up and running? So that's where your SLA becomes important. And so I still think of this as up down. It could be in out, which is probably a more service-oriented view, and I'm taking a server-oriented view, so I'm making my own mistake. But in essence, this whole notion of viewing it as a service rather than as a server is very important. So how do we make OpenStack fit this view? Now again, I might be making my own mistake, but the base OpenStack services really need HA. Keystone, your API services, your storage, if you're using Cinder or if you're basing stuff on Ceph, those, and what those really, when you think about it, those really don't have a whole lot of things they depend on. Usually their biggest dependency is probably MySQL or MariaDB. And if you start thinking of this as a service thing, we really need to get rid of this. It may have been a mistake to kind of take this server-oriented view of having controller nodes, compute nodes, and storage nodes. Instead, we should have been viewing these as services all along. So if I'm going to build a database service everyone's going to provide, I don't need to be deploying Galera and making it fit into my 3-node controller node model, I need to be built, I need to go back and talk to the MySQL gurus and build a highly available, scalable MySQL system. And that might be 3 read-write masters and a bunch of read-only slaves for if I'm read heavy, really having a good idea of what my characteristics of my workload are, and building something that can be scaled, can be backed up, can be upgraded, and so on. And if you treat every service like that, again, if you follow those contracts, then you're going to be really building a robust cloud. The problem is we came in with these hardware architectures, again, a server-centric view. And so we get a lot of complexity that we introduce by saying, okay, how do I fit all these things together when they don't really need to belong together? And a good example is if you look at the federated and Swift model, it's a ring. It's a completely different architecture than a lot of other things. And it works and scales phenomenally well. But trying to fit that into my compute controller storage model doesn't work well. Likewise, I use the MySQL MariaDB example. Ceph's another example of how you build a highly scalable Ceph cluster. Maybe we need to think about this with Keystone authentication too. But again, taking this service-oriented view versus a server-oriented view, you're going to build a better cloud. And it's hard when you're starting out. The other kind of dirty little secret is, and it really makes me sad when you get someone who's all excited, and maybe I just deal with this because being at a vendor and I'm a solutions architect talking to prospective customers, they're super excited. They want to go and move their organization to the cloud, and when they size it up, they need a grand total of like 3 systems, and that's 3 computes. And then you tell them they have to have 4 or 5 control systems and some storage systems just to implement those 3 computes, and they cry. And the problem is OpenStack really wasn't designed for that. It's not designed for small things because you can't build good services. I mean, you can build small services. And small services, but they're compromises, right? I can build a highly available MySQL system. The way I would do that probably if it's a small scale is put it in a VM that has HA. And, or maybe have a 3-node Galera cluster in HA, which is kind of what we do on our controller nodes. But, it's essentially treating my to use the whole pets cattle analogy, I'm treating my OpenStack services like pets. So it's having like a KVM infrastructure to run my highly available OpenStack services on. But OpenStack really shines as we get to scale. And so it's really, really being able to consume it at scale and design good services at scale and do it the right way means that it's really hard to package OpenStack in a consumable way, the same way we've done with Linux and with virtualization and other services. And I think that's partially why kind of bring it all back home, kind of why projects like Cola are good, because when you containerize these services, Kubernetes in particular provides you a great way of being able to scale out your services, and requires a lot of upfront thinking on how to build these pods, how to make them scale well. But you can start small and scale them bigger. And then if you need to, change your implementation, change it to implement it in a different way, and work those in and out of your service definitions and out of your load balancers. So, but we have to start thinking and have that service-oriented mindset to really make it work. And like I said, Cola is really my favorite. I've probably done hundreds of OpenStack deployments in the last few years. I hand-rolled a bunch in the beginning. I used a lot of automated tools like PackStack and Fuel from Ranis and OpenStack Ansible. By far the easiest one ever was doing Cola. I mean, it was the fastest and easiest thing, and I had something that fairly robust that I could really start whacking boxes in my Kubernetes clusters and stuff would stay up. And most importantly, when I dove into it and tore it apart, I knew it was in there. And I understood how it worked. It wasn't some magic voodoo scripting that people had done that kind of gave me this really snowflakey thing in the background. And what's nice is a lot of these containers can be put up into a Docker registry and just consumed. So again, you can set up your starting point of a relatively small deployment and have services that are optimized for these small deployments and have people pick them up and use them, but then also provide runways for as those things grow. So as they get bigger, once you get above X number of hypervisors, you should start looking at expanding these services in this way, or replacing your Neutron services in this way, or moving them to their own moving the pod to its own dedicated clusters. Here's how you build anti-affinity in here so that you can survive hardware failures, and so on and so forth. And also, because of the way Docker containers are built, they're programmatically built, which means that I can build my entire cloud through an entire CI/CD pipeline. In fact, that's how Moranis deploys their MCP. They basically set it up so that you're consuming source drops from them that run through a CI/CD pipeline and spit it out in your environment. And a lot of the people who've been really successful at consuming OpenStack at the source code level have built these CI/CD pipelines, but they've been really convoluted because they've been using Ansible or Salt or something to put these onto various bare metal. And again, they've kind of had to regress from having those nice abstraction layers from the metal, which is what we really want, so we can manage that separately. So other cool things for consideration as I wrap this up. And again, I'm not aware of anyone doing any of these things right now. If you are, let me know, because I'd love to read about them. If you get a wild hair and decide to do it yourself, just give me a little credit for part of the idea. One of the things is I think that rather than cramming our services into Keystone, we should look at something like Consul. And if you've ever messed around with Consul, has anyone used it? It's super cool. It's basically, you define your services and you can actually use it as a DNS interface. So you can sit there and say, I want the Nova API for my US East region. And it will give me you'll basically serve like a serve record from that I can then consume and pick up. And what's nice is it becomes I'm using DNS, first of all, which is a very standardized protocol for looking things up. But it's also nice because I can build geolocation. I can do generic services with geolocation. So I can just say, give me Nova API, and it'll actually give me the closest thing. Or give me Nova production, and it will just shunt me to wherever they want me to go. Whether let's say one data center is getting capacity, or one AZ is getting capacity, and want to start populating another one by default. They switch stuff in the background. I still make the same call, and it has the same. And again, it sets up a contract. I love that word. Can't you tell? It sets up a contract, which means that you can make that request, and they can provide the request in their own way. And as long as they're meeting their SLA, you're super happy, and they're able to do whatever they need in the back end. And it also has the potential to make things like federated identity much easier. Sorry. And again, it also scales very well. So you can start very small, where you only have one entry, and things that you build today with those basic entries can continue to function forever because you just expand in the background and make decisions in the back end, or add additional endpoints that then become specialized, while the initial ones can be alias to stuff that you change over time. The other really interesting thing is, as we deploy containers in Kubernetes, is being able to extend the APIs that Magnum and Courier provide to maybe also function in the public cloud. Because one of the biggest things that I've seen lately, everybody who's doing private cloud, almost bar none, is also doing public cloud. And they're sometimes it's right fit, right place. Sometimes it's just who picks what in the organization. Other times it's cost optimized. There's various reasons for doing it. But one of the things that I've always asked is, how can I burst my workloads into public cloud? Because I don't want to have to, it's the same thing as always. I don't want to have to plan for my peaks. I want to plan for my average. And public cloud's great because you can consume it at peak, and you can unconsume it when you don't need it anymore and go away. But again, you want to be able to you can have the same Kubernetes API, but from a management perspective, we might say, okay, you might want to do something like, okay, we're getting near we're doing, let's say, online retailing. And we start to spin up catalogs and spin up ordering and spin up other services. But instead of the developers having to deploy out new deployments into new places, I want to do it from the infrastructure level, saying, you know what, it's Thanksgiving's coming up, and we want to roll out and start holiday shopping for Black Friday. I just want to be able to extend my autoscale out into public cloud. So I want to be able to allocate container runtime space in the cloud, which is what the Magnum API does. So I don't really want to I want to be able to do that. Let's say I want to do it partially in GCE and partially in AWS, so that I don't have any, monocultural issues in case there's a cloud failover. And my developers and the rest of my higher level automation shouldn't really need to know. And maybe next year I want to do it on Azure in AWS or Azure in GC because the prices are better. And again, I shouldn't have to redo my upper level services and say, oh, this year I've got to point to the Kubernetes APIs in AWS and not in Azure. I mean, upstream of you in your contract, they shouldn't have to change. And also, it kind of helps to embrace that BYO pass methodology that Kubernetes is espousing. I mean, it's really, it was kind of a masterstroke of genius by Google to not only build their own container runtime in their public cloud, but also kind of essentially give the community the same runtime in the form of open source, because it creates de facto standard. And that means as a de facto standard, we should be able to manage it, and our end users could consume it in a consistent manner. And the more the way we can provide those types of endpoints for people to consume in a consistent manner, the more that we're winning, and the more that they're picking up the phone and getting their dial tone and they're happy with us. So now that I'm running out of air, this is my last slide. And as my final bad joke of the night, you can see it's an OpenStack of containers. So thanks a lot, you guys. I appreciate the time. Now, I'll open up to any questions or any discussion we want to have. But also, first of all, I want to ask, please, like I said, I've given this presentation several times. A lot of the changes I've made some small changes in it as a result of people's feedback. I'd love any feedback you guys can give me, whether you agree with me, disagree with me, criticisms, compliments. You don't like my graphics, my jokes suck, whatever. Oh, our hand already. I'm scared.
Are you going to post these slides somewhere?
Yes, this is the last one on my tour. I'm actually going to post it up at SlideShare probably when I get home tomorrow, and I will make sure I forward out the links to the various groups that have them.
Thanks.
So the last couple slides beyond this have some attributions to like where I got the PowerPoint template and where I love the graphics, but the contents of the slides are my own, and they're going to be through a Creative Commons license. So like I always say, good artists borrow, great artists steal. Steal the heck out of this. If you need this in presentations internally to help sell or convince or educate, take it. Just make sure you give attribution.
Yeah, this is cool. So one of your examples though actually kind of falls into this where you're talking
Sure.
about the phone system going down when everyone picks up a phone. And you actually virtualize the back end to that. And I send you a paper that one of our colleagues did it. We use that NTT Docomo where they actually put virtualize the whole IMS system, and then it could just bump off other workloads if a natural disaster happened after after Fukushima, because everyone was upset because the whole system went down and therefore they had to do it. So it's actually using virtualization, you can work past that issue that happened all the time with devices.
That's part of why telcos love the nature of OpenStack and why they're pouring tons of money into building VNFs, right? Because in the past, all of their endpoints were hardware, whether that was connecting to the POT system, connecting to cellular mobile systems, or even just data. And, same thing with other providers and content providers and I'm trying to find the most politically correct way to say it. People who run the large pipes that the internet run through. It's part of the reason it's becoming so like VNFs and DPDK and these other things are becoming super important, because the more this can be done in software, the more you have that bursting capability just in any kind of network function. It's just essentially another workload.
Yeah.
But very good point.
You talked a little bit about storage. What is your answer for storage?
What's the question about storage?
Yeah, well, like for containers and having a good shared storage, is that still to run that Ceph cluster on bare metal or something?
Well, I mean, the thing is there's two main types of storage you have to run with containers. There's just like with OpenStack, there's ephemeral storage of when you spin up a container where it runs, and then there's permanent storage attached to it. And if you talk to all the container smart people, they're like, don't do it. And it's like, well, okay, but what if I have to? I think for right now, like in the short term, if you're, run it the way, if I'm going to deploy, let's say Kubernetes on top of OpenStack, I'm going to set up my volume providers on top of Cinder volumes that are persistent that I can then, snapshot and backup and kind of have the cascading backup and restore policies. In time, when they have the integration with Cinder directly, which means when I go and instantiate a shared volume in a Kubernetes pod, it'll actually get a Cinder container. So like I said, well, last time I checked, which was last week, the blueprint for that is done, but it's not been implemented yet.
I mean, Kubernetes already has.
It does, but trying to yes, it does, but in most cases, tenants don't have access to API endpoints. And sure, you can do it, but the point is being able to do it in a way that, like, again, I'm an ops guy, and so it's like, and I wish I had it up here to have the little Jeff Goldblum thing from Jurassic Park. Just because you can doesn't mean you should. Yes, you can do it. And if I were going to deploy Kubernetes bare metal alongside my OpenStack, or I was going to deploy it at level that isn't in a tenant level, then yeah, I would definitely you can take advantage of that today. Ultimately, I want to be able to have, I don't want to have and you can kind of cheat and say, okay, these are special tenants, but as soon as you start making things special, then everyone's special and you have a problem, a security problem. And your security guys will go nuts because you're basically having to figure out a way to take tenant networks, wrap around and talk to your management lane, which is a big no-no for security guys. So yeah, you can, but until they really get that blueprint done and have it actually happen natively in Magnum, someone's gonna be unhappy one way or the other. And if you can live with it, great, go for it. But I also try to keep the security people happy at me, because then whenever there's problems, I'm not the one coming in at 3 in the morning to fix them.
I'll stop the recording, and we have more food.
Got another question.
There's another question about
It was kind of a piggybacking off of that storage aspect. You mentioned MySQL MariaDB as a dedicated. Can you maybe like expand on that? Like, you mean as containerized microservices, databases, and DBA tools, or?
Well, it's sort of like the context in which I was talking about was, in OpenStack land, up until very recently, almost every single deployment, whether you're doing RDO or, Red Hat's OpenStack, Ubuntು's, ours at Rackspace, Mirantis's, everyone had this notion of you had controller nodes and compute nodes and storage nodes and so forth. In reality, those were kind of the blueprints that everyone was talking about. In reality, when people were building big clouds, they weren't sticking their MySQL databases on the controller nodes like they are on those blueprints, because you become your own noisy neighbor, among other things, but also the rules for building a scalable, robust, secure MySQL cluster are different than, let's say, building a Swift cluster or building federated identity. And so viewing those as a service and doing what's best for that service at the scale you need is what I'm talking about. So it's basically not saying, so instead of trying to enforce my architecture and shove this peg into this hole really hard, it's looking at it and saying, okay, what's best for this service? We've proven that things like MySQL can scale to enormous lengths, like at places like Facebook. But I guarantee you, they're not running it on the same servers as they're probably not running on the same, I don't know, but they're probably not running on the same servers as their PHP stuff, or hip hop VMs, or their static, their static asset caching and stuff like that. Because you'd want to scale those differently because they function differently.
I wish my colleague was here, selfishly, who's more technical than I.
Yeah.
But I'm in Postgres world, so similar, but yeah.
Well, I'm a Postgres fan, but.
Incorporated, man. Anyway, my company's developed a Postgres container suite that containerizes Postgres and a lot of other microservices for the database, integrated with Kubernetes and Docker. And I'm admittedly more familiar with OpenShift and OpenStack, but I get the stack. And so I was just kind of interested to hear more about thoughts on that, because it's my understanding that traditionally the database has been outside of the as a service world.
Well, there's you got to remember, there's kind of two things. One, also, there's a big difference in, there's what, my customers, I don't mean my Rackspace customers, I mean as an ops guy, my internal customers, my people who consume the service I provide. There's a difference to the Postgres I'd be providing to them to consume and the Postgres that I'm using to provide all my infrastructure. And I'm a firm believer that, a lot of times people say, oh, it's like going back to the days of, there's, okay, let me put it this way. How many, remember the S3 outage that Amazon had a couple weeks ago? Remember why most people had problems? Because the green red status icons on the dashboard were served out of Swift itself. And so people couldn't tell what was broken where because Swift was broken. There's a real problem in thinking if you're consuming the own service you provide to indicate whether, and so you get into this, recursive vicious loop. It can be a virtuous cycle, but it also can be a vicious cycle. So I'm a firm believer in separation of concerns in that regard. So I may choose to run the Postgres that powers my cloud in containers, but that would be because I view it's the best way to provide what I need and do what I need to do. I may also choose to provide Postgres in containers because that's how I'm providing a service to my end customers, but different requirements, different consumers, and I shouldn't tie those two together just because then I'm basically saying that my requirements as a service provider are the same as my customers as a service consumer, and that's not usually the case.
Yeah, it's certainly not a one size fits all.
Yeah, that's the thing, and so the people sort of view it as a one size fits all, and to me, there's a big difference between the infrastructure you're providing, again, the management plane that's on the back end, and the services people are consuming on the front end.
Yeah, and I guess it fits more in a PaaS model than a IaaS.
Oh yeah, it could be. I could be running, my OpenStack in Cola, and I could be running it on Postgres and decide I want Postgres in my containers. That could be the way I decide to do it, and it fits my projected scaling for the next 5 years. So I do that.
Thanks.
Thanks, guys.
Some more food left.
More food left.
Thank you. This is great.
Yeah, that was great.
Yeah. So
You are welcome back anytime.
yes.
Oh, wait
So
till I have my next
Yeah. So there's more food and some to-go containers. So if you guys want to go in and grab a couple of things, that would be great. And then we can hang out and chat more. We're not looking to end everything, but we want to get the food put away.
Did you have a query thing you wanted to send out or something?
Oh yeah, and I have a survey. Please fill
Don't
this
forget
out
to
for
fill out the
those.
survey so he gets to maintain this facility for us.